3 years ago, I started my professional career as a software developer. And I remember going to Lunch and Learn, where we eat lunch and watch a tech video. And one of the first videos I've watched is actually by Julia Evans. I don't remember what she talked about. But I do remember how I felt. I was like, yo, one day, I'm gonna be up there. I'm gonna give a conference talk. So I was really stoked to hear that Julia Evans was keynoting at RubyConf Mini. Yeah, it's just really special because this is her first talk in 3 years. So let's give it up.
Amazing, amazing. It's working. All right. So I'm Julia. This talk is called Learning DNS in 10 Years. You might all have the zine I wrote about how DNS works, thanks to RubyConf for printing them, but this talk is not really about DNS, because, I mean, you know, this is a Ruby conference, right? So this talk is really about learning hard things, with DNS as an example of something that was hard for me to learn. And it took me maybe, I think, 16 years from like the first time that like I bought a domain name and I set it up with my DNS records to when I really felt like the system worked. And one thing I want to say at the beginning of this talk is that I think that taking like 16 years to learn something is kind of normal. I don't know, right? Like I feel like the idea that like, oh, I should understand this already is like a bit silly, because like I think for most of us, like in like our careers, I was doing other stuff for most of those 16 years, right? I had other stuff I wanted to learn. And so this talk is not about how you should know about like any particular thing. It's really about how like if you have a priority of like something you think is cool to learn, but that's hard, some strategies for learning it. So we're going to talk about learning through a series of tiny deep dives. My favorite way of learning things is to do nothing most of the time. That's why it takes 10 years, guys. So for like, 6 months, I'll do nothing. And then like, I'll furiously learn something for like, maybe 30 minutes, for 3 hours, for an afternoon. And I'll be like, okay, cool. I have leveled up my knowledge this much. And then go back to doing nothing for months, So I find this works really well for me. And I want to talk about a few strategies that I for doing these like little deep dives where we learn a little bit more. So first we're going to start briefly by talking about what DNS is, because that's the example through this talk. And we're going to talk about spying on the thing. We're going to talk about being confused, which is my main mode, I think, when learning. Reading the specification. We're going to do some experiments. And we're going to implement our own terrible version of DNS in Ruby. So what's DNS? Really briefly. So DNS stands for the Domain Name System. And every time you go to a website, for example, like www.example.com, your browser needs to look up that website's IP address. So DNS, among other things, translates domain names into IP addresses. It also translates domain names into a few other things, but mostly we're going to talk about IP addresses in this talk. And I want to briefly sell why I think DNS is cool, because we are going to be talking about it a lot. So there are two things I think are cool about DNS. One is that it's kind of like this invisible system that controls the entire internet, right? Like anytime your computer, your phone is like, you're using Google Maps, it needs to know like where is maps.google.com, right? Or if you're like on your computer, like where's reddit.com? What's the IP address? And if we didn't have this system, right, we couldn't, like the entire internet would collapse. Like all of our computers are using it constantly behind the scenes. And I think it's fun to kind of like learn how like this behind the scenes stuff works. I find it very fun. The other thing about DNS that I think is kind of interesting is that it's really old. I meant to write 1987 here, but there's this document which defines how DNS works that was written in 1987. And if you write a program, if you take that document and you write a program that works the way that document says to work, your program will work. And I think that's kind of wild, right? And I think it's really cool to take these kind of like stable technologies and learn them, because if you're gonna take like 16 years to learn the thing, It's not good if it changes a lot along the way, right? So the good thing about DNS is everything is the same as it was 16 years ago, and in fact, like 35 years ago. I think it hasn't changed. The basics haven't changed much since like before I was born. So like, we're good. We can be a little bit slow, and I like that. All right, so that's all. That's what's DNS. Now I want to talk about spying on DNS, which is one of my favorite ways to learn about things. I'm going to talk about two spy tools for DNS as an example of spy tools. We're going to talk about Dig. So Dig is a tool for making DNS queries. So we talked about how your browser is like, hey, where's maps.google.com? So we can do that in Dig. Maybe I'll do it in Dig. Oh, that's a little small. Let's get big. Okay, come on. Oh yeah, we're also going to learn out if the internet is working. So that's going to be interesting. Maybe I'm going to try again to connect to this network, but I don't know the password. Okay. Oh, I'm in. Incredible. Okay. All right. So if we look at maps.google.com, we have a little bit of information, right? But there's 5 things here. So let's talk about what these 5 things are. I've used example.com in this example. So we have the domain name, no big deal. The time to live, which is how long to cache that record for. So this is a 1 day. So it's like, hey, if you've got this information, it's good for the entire next day. You have the record type. A stands for address, because this is an IP address. And you have the content. But I think that the funniest thing about DNS is this thing in the middle, in, which stands for internet. Truly, legitimately. Because I think in 1983 or 1987, they thought that we might be on a lot of different networks. So they're like, we'll have tons of options for this. In reality, we're all on the internet. And every DNS query has there's a couple of others which truly almost nobody uses. And I just think it's funny that every time you make a DNS query, it's like, hey, we're on. It brings me so much joy. The other thing, and then we can also kind of poke around on the internet with Dig. So let's say, so we talked about A records, right? Let's say we can look up the IP address for example.com, but there are other kinds of records, like text records. So we're going to look at a text record really quick, just because I think this is very fun. On twitter.com, ooh, that's a little, we'll see if we can read this. All right, so text records are something that people use for domain verification. So if you want to prove that you own twitter.com, you don't own twitter.com, but we don't talk about that, I guess. But let's say you're using Google and you want to prove to Google that you own twitter.com. So what you can do is you can set this DNS record, Google Site Verification H6DJI, on your site. Like they'll tell you to set that, and then you'll do it, and then they'll be like, all right, I believe that you own twitter.com. And so I think that's kind of fun that you can like kind of poke around in DNS and be like, oh, Twitter is using like Miro or Traction or Canva or Mixpanel, and it's all public and it's all there. And I just think that's fun. I like to like feel like I'm getting like an inside peek, I don't know, on what people are doing inside their companies. So that's Dig. Oh, the other thing about Dig is that by default, Dig looks like this, which I don't want to look at personally. Like there's a lot of nonsense here. So Dig has a configuration file where you can put plus no-all plus answer, and then your Dig responses look normal and nice instead of having a lot of nonsense. And I just think that I just really feel like our tools should serve us, and whenever possible, I try to make my tools behave in a more human way. The other thing I want to talk about is Wireshark, which is my favorite computer networking tool in the universe for spying on like all things computer networks, in this case, DNS queries. So let's go look at Wireshark. We're also going to have to make this bigger, but we're going to be okay, I think. No, 53, come on. Capture? Yes, okay. So when we make a DNS query like this, we look up example.com. Wireshark can capture it. And so when you kind of like look in the guts of things, I think it could be a bit scary at first. Like there's all these like what is all this over here? You know, like it kind of seems like a lot. And when I'm looking at something new that's like kind of like under the hood of how my computer is working, I try to start by looking at stuff that I understand. So for example, I know that example.com is a domain name, right? And so I see that, that's good. We talked about how A is a record type. And if we look in here, we can kind of see a little bit more about what's happening. So like, because the thing about DNS queries is like, it might seem kind of complicated, right? Like there might be a lot in there. But the fun thing is that if we go look to see what is involved in making a DNS query, there's 3 fields. The first one is the domain name you want to know about. The second one is the type. And the third one is the class, which is internet, which is always the same. So like, there's really only 2 things. You're just like, I want the IP address for example.com, which is kind of exactly what you would think. And I find it just like fun to like look at the inside of something and be like, oh, this is simple, you know? Like there's not that much going on here, even if it kind of looks sort of intense. There's just 2 fields. And that always makes me feel a little bit better about understanding something. There's a quick caveat that if you're using, sometimes now we're using encrypted DNS, and this will not work if your DNS is encrypted. But there's lots of non-encrypted DNS to spy on. All right. So the second thing I want to talk about for learning new things is to notice when you're confused about something. So I want to tell you a story, the case of the mysterious caching of something that happened to me with DNS that really upset me. So to understand this, I need to talk to you for a little bit about how DNS works, a little bit more. So on the left here, you have your browser. And when your browser makes a DNS query, it asks a server called a resolver. And all you need to know about the resolver is that it's cache, which as we know is like the worst thing in computer science, right? So the resolver is cache, and then it asks kind of the source of truth, which has the real answers. But this thing in the middle is just a cache. So yeah, your browser talks to resolver, looks in its cache, great. And I had this mental model for like how I thought about DNS, which is that if I set how long something should be cached to a short time, like 5 minutes, then I would never have to wait more than 5 minutes. Something you need to know about me is that I'm a very impatient person, and I hate waiting. So I had this model, and it was mostly working for me at the time. There are some other very important caveats to this that I'm not going to get into. But this is like sort of the short version. So this was working. And then one day I was setting up a new subdomain. I was doing some new project. Let's say it was new.jvns.ca. So I set it up. I made its DNS records. And I refreshed the page. And it wasn't working. And I was like, okay, you know, that's fine. My model says I only have to wait 5 minutes, right? Because that's what I was used to. And I waited 5 minutes. And it still didn't work. And so I was like, oh no, right? Extremely smart thoughts. So my mental model was broken. I did not feel good. And often when this happens to me, like to be honest, I think most of us, if something weird happens with a computer, you let it go, right? You're like, okay, I don't know. I guess I have to wait longer. I'll just wait longer. But sometimes I have a lot of energy, and maybe I'm feeling mad, and I'm like, the computer can't beat me today. Like, there's a reason that this is happening, right? And I want to find out what it is. So this day, for some reason, I had a lot of energy, and I was like, you know, I will Google it. So I started Googling furiously, and then I found out this thing on Stack Overflow that said like, yeah, right. I went to Stack Overflow. And I found out about something called negative caching. And so here's what was going on, or here's what it said might be going on. So instead of getting an IP address back, it got kind of like a negative answer, like, hey, this domain doesn't exist yet, the first time that I went there, because I visited it before I'd created the record. So it was like NX domain, which is DNS's way of saying, like, this doesn't exist. And the resolver cached that. It's like, great, that doesn't exist. I'll remember that it doesn't exist. which is not good, right? So then I made it and it did exist, but it was cached. Like the fact that it didn't exist was cached. So like, that's kind of bad, right? And then I had this question, which is like, how long do I have to wait for this thing to exist, right? So how do you know? This is going to bring us to another learning technique. I think like maybe the most upsetting learning technique to me, just like read a very boring technical document. And again, I'm like very impatient. I kind of hate reading. And so when I do this, I like to bring a specific question. So in this case, I had a specific question, which is like, how long do I have to wait, right? Like what, how long do I have to wait? And so in networking, I think kind of everything has a specification and like boring documentation about it. In computer networking, the boring technical documents are called RFCs for request for comments. I find this name a bit funny because for DNS, one of the main RFCs is RFC 1034, 1035. These were written in 1987, and the comment period ended in 1987. You know, like you can no longer make comments. But so it's really like just this is how it is. But I guess maybe this is how it is not a good acronym. Anyway, whatever. They're called RFCs, and they exist for lots of different protocols. I personally kind of love them because they're like the ultimate answer to many questions. So for HTTP, you have RFC like 9010 to 9014, etc. But we're going to be talking about DNS. DNS actually has 1 million RFCs. It's very upsetting, but the answers are often there. So I went looking. And I think I went looking because I saw some information about this, but sometimes when you read comments on Stack Overflow, like I don't always trust them. I'm like, are you telling the truth? Do you know? How do you know? You know? And I really wanted to go to the source of truth. So I found this document called RFC 2308, where in section 3 it says, like, this is not very exciting. It says, like, the TTL of this record is set from the minimum of the minimum field of the SOA record and the TTL of the SOA itself. It indicates how long a resolver may cache the negative answer. Just like, okay, cool. Like, what does that mean, right? It's like, but you know, luckily we only have one question, and I don't need to read the entire boring document. I just need to like analyze this one sentence and figure it out. So it's saying that it depends on sort of 2 fields. So I want to show you how to sort of look at this. So if I look up new.jevons.ca as a domain which continues to not exist, I could actually do anything here. I could do like this also does not exist. So there's no answer here. It'll be like NX domain does not exist. But it also returns this thing called the SOA record, which is kind of like some like domain metadata. And there are 2 fields here. Here, I made this on a slide to try to make it a little bit clearer. So there's this field at the end that's called the minimum field, in quotes, and then there's this other field that's the time to live of that record. And so what it's saying is that if something doesn't exist, the amount of time it's cached for is like the minimum of those 2 numbers. And so it turns out that that's how long we have to wait. We have to wait 10,800 seconds, also known as 3 hours. And so I waited 3 hours, and then everything worked. And I found this kind of fun to know because often, like if you look up DNS advice, it'll be like, hey, if something has gone wrong, you need to wait 48 hours. And I do not want to wait 48 hours. You know, I hate waiting. So I love it when I can like use my brain to figure out like why I can wait for less time and be impatient. And this totally worked out. And then the cool thing about this is that I was like, oh, cool. Like now I know like the answers of caching, right? Like now I know how DNS caching works. And like when my mental model is broken and something happens that I don't expect, sometimes I feel like I don't understand anything, right? But in this case, and I think in a lot of cases, there's often just a few things I'm missing, right? Like this negative caching thing is like kind of in the weeds, but it really was like the one thing I was missing about how DNS caching worked. There are more things to it that I didn't talk about, but like in this case, it was the one thing that I needed to learn. And that really felt good, because it's like, okay, I need to like make this investment and like spend time reading this RFC or whatever. But then I know, and I haven't run into, I think, more problems that I didn't understand since then. Though I'm sure there's something else out there that I don't know. And I want to say briefly, there's like a solution to this problem for DNS. So we talked about how like if you visit something before it exists, it's non-existent, it gets cached. And the solution is if you haven't set up something's DNS, don't visit the domain. And then it can never get cached, and then you have no problem, right? Only visit it after you set it up. So I've learned to do that, and now I never have this problem anymore, and I do not need to wait 3 hours, which is really great for me. All right. The next thing I want to talk about is doing experiments. Oh yeah, and I want to do like some experiments with caching. I think in particular with DNS, I think I have like maybe less fear than other people around computers. Like often I'll be like pair programming with a friend and they'll be like, what if we do this? And I'll be like, I'll just try it. They're like, what if you break something? And I'm like, I don't know. It's probably fine. And I don't really know if I'd recommend this approach, but it is usually fine. But what I've learned by talking to other people is other people have more fear than me about experimentation, and in particular around like DNS and their domain names. Like they don't just want to like enter random stuff and see what happens, which I think is understandable. Anyway, oh yeah, that's what I was talking about. Like, what if I break something? And so because I was really into DNS and I wanted to experiment with DNS, and I also wanted other people to experiment with DNS. I made this little website with my friend Marie called Mess with DNS, where I was like, if you don't want to do DNS experiments on your domain, you can do them on my domain. And if you mess something up, it's my problem. It's not your problem. And there have been no problems. It's been totally fine as far as I know. So I want to do a little bit of DNS experimentation. I'll make this a little bigger. So the way this works is you get a little subdomain. This one is chair131.messwithdns.com, and then you can make DNS records there and try stuff out. So I want to show you. We talked about how DNS records get cached. I think I have a slide about this again. Right. And so what we would expect to see is that if we make a query, then it asks kind of like the source of truth, which we control. And we should expect to see only one query, right? Because it's cached. So I want to do an experiment and see like if we make a subdomain test and I set its IP address, what should I set its IP address to? Does anyone have an idea? Just some numbers. Perfect. Great IP address. Thank you. All right. So I have this subdomain, and I'm going to make a few queries for it. Just quickly. All right, 7.7.7.7. Amazing. Okay, so I've queried for it, a bunch of times, like 10 or something. And if we go look to see, oh, cool, this isn't what I expected to see. I'm upset. Okay, this is fun, though. This is a little different. That's great. Okay, so we made maybe, how many queries did we make? 10? Let's make some more. Wow. Okay, yeah, all right. We made maybe 20 queries. And then we see that our server got 1, 2, 3, 4, 5, 6, 7, 8. Eight queries. So like that's kind of fun, right? So I think the thing I love about experimentation, part of the reason I wanted to do this live on stage is that sometimes what happens isn't exactly what I think, because we saw that it was cached, because we made 20 queries and like to the resolver, but then the resolver only, like these things that we're seeing are kind of are on the other end. So we only saw like 8 queries here, and I assume that this is because the resolver we're talking to has like more than one independent cache. that we're talking to. When I do this experiment at home in Montreal, it works differently, which I find very fun. I think maybe it means that like the way Cloudflare's network is set up here is different from in Montreal. I don't know. Anyway, so this is cool. And like I think what's kind of interesting in doing experimentation like this is it sort of like complicates your idea about how caching works a little bit, right? Because you have this idea that things are cached, and they are, but like maybe a given DNS resolver actually has like 2 caches, and which one you get is random, and so like you're not always talking to the same one. I think that's what's going on here. We could also ask Google what it thinks about this domain name and see what it does. It's a little slow. My server's a little slow. All right. And we're seeing kind of a similar thing here, I think, where some of them are cached and some of them are not. I'm not really going to go into it. It's a very similar situation. Cool. That's an experiment. We could also do an experiment with negative caching, which could be fun. Let's try it out. So I'm going to ask for this domain name. This is not going to work. No, I'm not going to do this demo. Sorry. I can just see it going downhill. We're going to move on to implement your own terrible version. The problem is that there's too many different caches, and I really want there to be one cache. But there's like 7. Anyway, it's fine. I'm going to talk about my favorite strategy for learning about stuff, which is to write my own very bad version of the thing. And I want to say that like writing my own very bad version, I feel like gives me like an unreasonable amount of confidence. And so like you might think that writing like DNS software is complicated, right? But I want to say that like I think it's surprisingly easy, and I think that writing your own terrible version of something is often like easier than you might think, as long as you keep your expectations low. And so to make DNS queries, the first thing we need to do is we need to make a network connection, right? So we need to talk to a DNS server. You might recognize 8.8.8.8 as Google's DNS server. So we need to connect to that, and the DNS port is port 53. So to do that, that's just 4 lines of Ruby, right? Like we're like halfway there. So after we've made a connection, we need to send Google a DNS query, right? And you might be like, Julia, I don't know how to write a DNS query. That's the whole problem. But there's no problem. We can copy it, right? From something else that knows what a DNS query looks like, aka Wireshark. So if I right-click on this thing, this is a little small, but I'm clicking on copy and then copy as hex stream. No, I did it wrong. Okay, I should look at the screen so I can actually see what I'm doing. Copy as hex stream. I get this thing, which is a little bit impenetrable. You know, like I don't know what this means yet. Necessarily, but this is a DNS query. And you might think that like, hey, you can't just copy and paste something and then send the exact same thing and it'll reply, but you can. And it works. And I'm gonna show you what the code looks like. There's very little of it. So we take this like hex string that we copy and pasted, and then so this is a way of representing a byte string. So like B9 is 1 byte, and then 62 is the next byte. And I can use .pack in Ruby to convert that into a string of bytes, and then I can just send it. We're going to do that right now, and we're going to see it working. Let's go to Wireshark and ask it. I'm just going to ask it again to start like, oh no, not save, sorry. Continue. Okay, I'm going to ask it to look at my UDP at my DNS packets, and I'm going to take this little DNS program that I wrote, which you can see has very little code in it, just the same code we talked about, and we're going to send it, and we're going to see what happens. All right, we've sent it. Okay, there was some other noise in between. I'm going to stop this capture so that more things don't happen. But this is the query we sent. You can see it starts with B962, which is exactly what we talked about there. B962, that's the ID. So we sent a query to Google's DNS reservoir, and we got a response, right? It was like, this is totally legitimate. There's no problem. Because, I don't know, it is totally legitimate. And there is no problem. I don't know, we're DNS wizards already, you know? It doesn't know that we just copied and pasted that and we don't know what it means. That's fine. Okay, but like, you know, we do want to know what this means, right? This is a little silly, even if it's a good starting point to know that our thing is actually working. And so I want to take this string and I kind of split it up into two parts. So for the first part is the header, and the second part is the question, which contains the actual domain name we're looking up. So I want to talk about how to construct these things in Ruby, and how it's not very hard. So firstly, I want to talk about what a byte is for 1 second, because it might seem kind of intimidating. So this thing B9 is like the hexadecimal representation of a byte. The way I like to figure out what that means is just type it into IRB. If you type in 0xB9, it'll be like, oh, that's the number 185. You know. So it's like it's pretty easy to figure out what these things correspond to by like typing them in. So this is 12 bytes, and that corresponds to 6 numbers, which are sort of 2 bytes each. So the first number is this thing B962, which is the query ID. That corresponds to the number like 47,000 or something. And the next number is the flags, which basically in this case means like this is a query, like hello, I have a question. And then there's 4 more sections, the number of questions and then the number of answers. We do not have any answers. We only have a question, so we're saying, hey, hello, I have 1 question. That's what the header means. And the way that we can do this in Ruby is we can make a little array that has the query ID, whatever we want to send it. I gave it a parameter because I figured maybe we should have different query IDs for every query because it's like a good programming practice or whatever. Instead of and then these numbers which correspond to the other parameters. This is the flags, and then there's 1. I don't really know why I typed 0x001. This is really literally the same as just typing 1, 0, 0, 0. And then we need to tell Ruby how to take these like 6 numbers and then represent them as bytes. So n here means each of these is supposed to be represented as 2 bytes. And anytime you take a number and you represent it as bytes, you need to decide what order to put the bytes in, sort of forwards or backwards. This is called like little endian or big endian, which I think is really funny because it's like after something in Gulliver's Travels where they argued about like whether it's better to have like your egg on the big end or the little end, because people used to argue about this a lot and they decided that doesn't matter. Anyway, but nonetheless, because of history, it's very important which one it is, and you need to do whatever the other one expects. Anyway, one of the byte orders is helpfully also called network byte order, which I think is what I don't know if that's what the N is for. Anyway, one of the orders is called network byte order, and it's what it's used when you do networking. So it's very easy to remember. It does the same as big endian. Anyway, so here's our like 1-line function. And that's how we make the header. I don't know, it works. It gives us the same thing. So the next thing we need to do is we need to make this question, right? We need to figure out like, okay, what does this mean, right? This kind of seems like a lot. So I broke it up here. So it has there's 2 parts you might recognize. We're looking up example.com, so there's example and com. And so the way this works is it has a number, which is like the number of bytes in that part. So example is like 7 characters long. So it's like, hey, you have 7 things, and then there's example, and then there's 3 things, which is com, and then you end with a 0. So example.com is 7, example 3, com 0. And then at the end, you have 2 more things for the type and the class. The class is always internet, as we know, so you don't need to worry about that. And 1 is for IP address, if we want to look up the IP address. We can write a little bit of code to do this. If we want to translate example.com into 7 example 3 com 0, we can like split the domain on a dot, and then like get its length, and like concatenate that together with like that part of the domain, and join it all together, and then put like the 0 on the end, and it's like just a little bit of Ruby, you know. I don't know, I feel like it's so nice. So that's how to encode a domain name, and then we can kind of wrap all this together where we make a random query ID, and then we make the header, we encode the domain name, and then we add the type and the class, which is one for internet, and then we can just concatenate them together. We're like, we have the header plus the question, and then that's how we make our query. I want to show you, so there is definitely more work to do here if we want, like that's how you send a query. That's literally all the code, right, to send a query. You do also need to decode the response, which is a little bit more work, but I want to show you a quick demo of how this works. What's a domain name we should look up? RubyConfMini.com. All right, let's do it. Hooray! And this is only, I forget how much code this is. It's like 120 lines of code. So there's like a little bit more in there. I have a whole blog post that breaks down the whole thing on my blog. It's like my most recent blog post. If you want to learn more about like how to decode the response, like how to do all the bits and bytes, I don't know, I found it very fun. Yeah. All right. We're at the end. Let's do a recap. Okay. So the ways we have talked about learning about things are to spy on it. I find that when I look at things, like to see like really what's happening under the hood, and when I look at like what's in the bytes, you know, what's going on, it's often like not as complicated as I think, and often kind of like not as complicated as people told me it was, you know. It's like, oh, there's just the domain name and the type, like that's all. I feel like it's often not a big deal, and it really makes me feel more confident that I understand the thing. I like to try to notice when I'm confused, and I want to say again that like I feel like noticing when you're confused about something is something that like we don't always have time for, right? And it's something to do when you have the energy. For example, there's like something weird here that's happening. Oops, wrong way. Where like when Cloudflare looks this up, we looked up this domain name, like test.chair131, but it also looks up chair131.messwithdns.com, like kind of the parent domain, and I don't know why. Like, I'm confused about that. And I have noticed it, but I've also ignored it at this time, I guess because I'm in the middle of giving a talk. So I think it's good to notice, and then like you can decide what to do and when you have the energy. Maybe I will look that up one day, but I haven't yet. Maybe someone knows the answer and will tell me. I don't know. The other thing, we talked about reading the specification, which I feel like is really like, I feel like there are a few times I feel like more powerful than when like someone has a question or well, maybe I'm in like a discussion with someone, they're like, you know, it's like this, and I'm like, well, I read the specification. And I know that in RFC 2308 section 3, you know, I think it's really fun, and it's like just like a nice way to feel certain. And I feel like very few people are like willing to read the specification, because I feel like it kind of sucks. So I think it's like a fun like little superpower to have. I love to do experiments to like check that my understanding of stuff is right. Often I learn that my understanding of stuff is wrong. I had an example in this talk that I was going to include, and I was like, you know, I'm just going to do a little experiment to make sure this works how I think. And I was like, oh, nope, that's I was totally wrong. And now I know, you know, and I feel like actually doing experiments is often one of the quickest things, because you just kind of like poke at the thing and then you see. And I feel like there's like, I mean, unlike experiments on like, I don't know, things in the physical world, on computers there are usually no consequences for experimentation, which I really enjoy. So you can do silly stuff, see what happens. And then the last thing we talked about, and truly my favorite, the most work, is to like implement your own terrible version. I think that for me, like, the confidence I get from writing like a terrible DNS thing that has resolved like 11 different domain names, right, is unmatched, you know? Like, if my thing works at all, I'm like, wow, you can't tell me I don't know how DNS works. I implemented it. You know, and it doesn't matter if like my implementation is very good, because I know that it works, right? Like I've tested it, I've seen it with my own eyes, and I think it just feels amazing. And there's also kind of no consequences for this, because you're never going to run it in production. So it doesn't matter if it's terrible. It just exists to give you like huge amounts of confidence in yourself. And I think it's really nice. That's all I have to say. Thank you for listening.